my name is Suyog. I work as a senior research data scientist at dunnhumby. So I have joined dunnhumby 2 years back. So before working at dunnhumby, I completed my masters from University of Texas. My major was in AI and databases. So currently in dunnhumby, I work around developing an automated machine learning platform for our organization. And I also work on developing POCs around knowledge graph, NLP, and data science as everything. Like, so the three dots that you see are most important, I would say, in the last line, because I'm still learning. So that's what is required in every data scientist. So after that, looking at the organization dunnhumby, if you have been there in Victor's talk, you might have seen this slide before. So I'm not like again putting it just for the sake of it, but there is a context to it. Like, if you see, we have around 76 retail clients, 1000 plus CPG clients, then we have around 44 billion baskets going on every year and so on. So we have clients almost in every continent you can see, and Tesco being our biggest client in UK and Europe. We are a sister company or a child company of Tesco. So this is just to give you a scope of different entities interacting with each other in dunnhumby or as an organization. So you can generalize this to any organization or any different entities interacting with each other. Yeah, and then so the way we work in dunnhumby is like when we get any projects. So analysts who get any projects, they start working, start collecting data, and if the project is something new for them, they ask question like this on our internal like social media platform, which is Yammer. So Yammer is similar like Facebook, where people can post their queries and you get answers like this. So the question can be something like this: and do you feel like this is not the most efficient way of getting an answer to a particular problem that you have, right? So you get replies, but that might be 2 hours later, 1 day later, and so on. But if you want some instant queries, some queries to be solved, this is for sure not something efficient. Also, there are many different things interacting with each other. So we have, if you go to dunnhumby's website, there are 4 different capabilities in retail which we address. Then there are catalogs inside each of the capabilities. Then there are solutions in each of the catalogs and algorithms on which the solutions are built. And there are tools which are been supporting those solutions and so on. So if you look at it, the first component, the first 2 components are connected, whereas the others don't have like direct connection with each other. So if you go and ask, like, I want to know how many solutions are been running in a particular catalog, we will have to dig in deeper to find the answer to those solutions. So that's a particular problem or particular hurdle that we need to solve. And if you look at the structure, here, you find interaction, you find different entities and their interactions with each other. And those entities, if you try to look at it, this is basically a knowledge base, and because there is a relation and there is interaction between each of the entities, we can easily build something called a knowledge graph on top of it. So how many of you are aware about knowledge graph or have used knowledge graph? So I see only 2 or 3 hands coming up, but I can assure you that we all have been using knowledge graphs even just 5 minutes back, right? So can you take a guess now, like, what is a knowledge graph? Right. So I will just give you an example of what is a knowledge graph. So what do you see when I type Python? Something appears at the right when in the Google search. anything you type, something appears at right of the Google search. So if you have realized this was not the case with respect to Google search, like before 2012, when you used to type, you just used to get links, you just used to get results or links to the search, like the web pages. But this is something that Google has implemented, and this is actually a knowledge graph implementation. So what do you see here is these are things and not just strings. So if you go deeper into understanding the result of the query, Google is not just giving a result for Python. It is telling you what Python is, when it, who was the means how who has designed Python, then what are the different IDEs that Python has, and so on. So you don't get just an answer, but a detailed, like an information about what that particular query or the answer is. So Google started it in 2012, and by 2016 they had covered almost one third of the answers that people asked were answered directly through the info box on the right. So people got their answers from the right, like the info box which you see there. So that's just to tell you how powerful a knowledge graph can be if we utilize it to its efficiency. Then going to the next thing. So this is about Google, Amazon, Facebook. They are all bigger companies and bigger entities. So if I, as a person like working for an organization, want to develop my own knowledge graph, I need to understand the basics of it, like what is a knowledge graph, right? So just to define quickly, knowledge graph is a semantic, smart, and alive graph. So the name itself like explains you that it's a graph, but what's it? So it's a semantic. So everything in that particular graph is interrelated. So you cannot have abruptly anything inside the graph which is not related to the next thing around it. So there is a relation between all the different components in the graph, and that relation also has a particular name, right? Then it is smart. So smart as in, I can give you example of how smart means how we can define a smartness. So we all know, like in our Indian culture, we all know different relationships, right? Like we call them bua, then tau and all. So uncles, like my father's brother, we call him tau. Then for our father's sister, we call her bua. So that's the relationship, like that's something smartness I would define. So if this is with respect to the different entities interacting. So if I say A is related to B and B is related to C and C is related to D, then drawing an inference that A is also related to D, that's the smartness we are talking about. And it's alive. Alive means any time, any point of time, you can add a new thing in that particular knowledge graph, and you can enhance that knowledge graph to its current potential, right? So these are different use cases where we can solve, where we can use knowledge graph for. One, the most common is to like to design an intelligent chatbot. What goes behind is the knowledge graph, like different entities interacting and solving a particular problem through the questions. Then semantic search engine. So the intelligent chatbot and the semantic search engine, I would say, both go hand in hand, where we don't only want to give results, but if someone is asking for an apple, we just don't give him result for apple, but specific kind of apple. So a detailed or meaningful result to his queries. And then for advanced drug discovery, like in with respect to the drug discovery, we know that if there are ingredients for different drugs, the disease against which the drug is used has different symptoms. So there are we can identify that there are entities and their relationships, and we can identify what are the different, like how we can use this drug for another disease which has similar symptoms. So that we can do through knowledge graph. Then what are the tools that we have? So there are these, I have just listed 3 of the tools, but there are many more knowledge graph tools which are available in the market. So if you understand knowledge graph, it's basically a database, but this database has additional features which uh, makes it easy to draw graphs from that particular database. So we are going to talk about GRAKN. So GRAKN is an intelligent database, and it's also a knowledge graph. So it is a new company, like a new startup formed like three years back, and it works in the knowledge graph domain, to be specific. The way the power of knowledge graph and what it of GRAKN and what differentiates it from all the other tools are its main features. So the first one is basic, like knowledge schema, where you can define schema, and it like if most of you are from computer science domain and learn databases, we all know, or we all have learned about ER diagram, right? Entity relationship diagram. But the thing what happens is, after a little while, we tend to forget that concept and just design databases, and we don't understand the relationship between the databases. So knowledge schema is enhancing or using or utilizing the ER diagram, or the potential of entity relationship to its to its maximum, and using this you can define different relationships and different entities. Then the next one is distributed analytics. It can do like it can solve algorithms like mentioned here, Pregal and MapReduce. So which are basically, Pregal is a algorithm used in page ranking by Google or any of the search engines. If you see, for page ranking it uses Pregal, whereas MapReduce, as we all know, is a distributed computing algorithm. So it can do distributed analytics as well. Then it is high level language. That means you don't need to go into nitty-gritties of that particular language. All the abstractions have been made in the language, so you just need to worry about your business problem, or just defining your problem, and all the internal computations are taken care. And the most important feature in GRAKN is its automated reasoning. As I explained before, the inference part, where here it uses logical real-time inference, where it uses type-based as well as the relation between the entity and relationships. So they have a concept called hyper entity hyper relationships, which uses, or which has been heavily utilized for automated reasoning. So so these are the main features or main qualities of GRAKN. And if you look at the components of GRAKN, this is a particular just a basic example or basic stack of GRAKN. GRAKN is formed of a core, which we can call as a server. So that server contains Cassandra's database. So Cassandra is a NoSQL database, as we all know, and on that NoSQL database we have different type of clients. So as we can see, it supports 3 basic languages as of now: Python, Java, and Node.js. So whatever data has been saved in the GRAKN core, you can use that data. You can get an output in these 3 different type of clients. So there is the GRAKN query language as well. So this is similar to the SQL. So like in SQL, we do select star from a table name. We similarly can do match $A. We'll see the details, but this is similar to the SQL query language for GRAKN. And they have a GRAKN workbase as well. So GRAKN workbase is basically the IDE for GRAKN, where you can connect to the database which you have. Yeah, and they have their own enterprise version of GRAKN core, which is been managed by them. So so you can take a look on their website. Yeah. So just to give you all an demo of what GRAKN looks like. So this is an interface of GRAKN workspace. Uh, the query language which I just spoke about. So if you look at the syntax, it's similar to SQL, where in SQL we use select, in GRAKN we use match, and the query goes on like this. But the output that you see is not in form of tables, or it's in form of graphs. So we'll just quickly go through an example of GRAKN queries. So these are few pre-opened tabs in case the internet doesn't work, but I can show you a demo as well. So can everyone see the search or the query box and all? So these are basically pre-written queries. So if I want to see all the, say, the capabilities in NumFOCUS, so these are basically 4 different capabilities. So if you do the same thing in SQL, it will give you a table with 4 rows, whereas in GRAKN you get something like this. I don't think we can. So you will have to sit here for that. So I will explain you through another queries. We have pre-saved queries for that. So this is a query where we try to see what are the list of projects which were been created in capability customer knowledge in the first quarter of 2019. So we are limiting the result to only 1 because we want to show it very quickly and move ahead. So the way it works is, if you see, this is an entity named project, whereas this is an entity named capability, and if you click on this, so this is basically a relationship. The dot that you see is a relationship, and when I click explain, it will, yeah, it is running. So it will start giving me what is the relationship, why this particular project and this particular capability is connected. So let's just wait for a few minutes. So this is the catalog. Segmentation is the catalog which is been connected to the capability. I would say it's a means the data is same with respect to the data is similar to what we have in relational databases, but what we do internally is we define rules and define schemas. So rules is where we define, like a sister's, like my father's brother is my uncle. So those relationships are been, or those inferences are been formulated in form of rules, and those rules, if matched against the data, we identify a relation, is what we see here. Yeah. So but if you look at the overall, like how we typed the queries, it is not at all an easy way of, if you tell a normal user to do, like on Google search, type that query, he won't be happy in doing that. Or even with respect to any organization, if you tell your manager or your executives to type a query like this, like what we saw just now, and get a result, he won't be happy in using that. So what we want is something like this, like a converter which converts your question which you type into a query like this. So that's our aim. So schema, if I told you, like the schema, which is basically entities and relationships and their connections, is the mirror of what we speak. So we, for the inspiration, we went to different papers, and this is what we found. So if you just Google, go to the entity relationship page of Wikipedia, you will find this diagram there, which explains the relationship between a natural language and the entity relationship construct. So what it tells briefly is, noun can be treated as an entity and verb can be treated as a relationship. So there is a connection between how we speak and the entity relationship diagram that we draw. And also we came across a paper. So this is actually a blog on GRAKN, which talks about converting texts into a knowledge graph. So there, this was a useful paper which we used to convert our like queries which are in natural language to GRAKN queries. So for the nitty gritties, for the NLP part, so you might have heard about this in 2-3 talks up till now, where we wanted to identify what are the noun and what are the verbs, because we are going to treat noun as entities and verb as relationships, relations. So that's why we use Spacey, and in Spacey we have POS tagger, which is part of speech tagger. We use that part of speech tagger to get noun and verbs. Then we used Gensim and Glow. So these are word to vec algorithm. Gensim is a Gensim is a library where we have many word to vec packages, and Glow is global vector representation, global word vector representation. So we used that particular part, or we used a model like a pre-loaded model from Glow, or it was of a Wikipedia and a globe word model. Using that model, what we did was, yeah, I will tell you what we did after a while. But we hosted this onto our Flask using Flask API and Docker. So the flowchart was something like this. Let me go through it this quickly. We had a question, then we converted that question in through POS tagger into noun and verb. The noun, first we identified if that noun is a part of our entities which we have saved in databases. If we find that entity, we directly use it to create a query. If no, then we identify if it is an attribute to that entity. So we try to find it in our database, like the values in our database actually. If we find any value, then we use it directly as a noun. Even if we don't find it like exact word or exact phrase in our database against the attributes, what we do is try to find using the word to vec model that I just showed you. We use that to find a similarity between that text and some word in our database. So we infer that this particular, if the similarity is more than a particular threshold, we infer that this particular word or phrase is talking something similar to what we have in the database or in the entity table. So that's how we use, and we repeat the same process for relationships as well. And at the end, we so this is a demo. So the things which are loading. So this is basically, I will quickly show you the actual demo. Yeah, and in the future enhancement, we have the plan like what someone just mentioned of converting the data set, or someone just mentioned Wikipedia's, can we use Wikipedia as data set, right? So that is something which we'll have to do here. So even we have many PDFs or many case studies in form of PDF and Word and like PPT format. We want to convert them into GRAKN representation. So we are going to use the same approach as you can see on the right, and the other is answering like user questions through intelligent chatbots or semantic search engines. So these are the references, and yeah.